In this video, I'm just going to take a look at a few additional examples about how to solve polynomials algebraically, depending on what type of form they're in. So in this problem, our first goal is to get the parentheses and the exponent by itself. So I'm trying to isolate this part of the equation on the left-hand side. That means I got to get rid of the -3 and the 1. The first thing I want to get rid of then is the addition. So I'm going to subtract 1 from both sides. And then I'm going to go ahead and get rid of the -3 by dividing both sides by -3. Because, of course, right now in our equation, it's -3 times the parentheses. That's why I got to divide there. And so now I have x plus 5 squared equals 3. No, I do not want to multiply it out and actually square it out. Instead, I want to get rid of the exponent. I want to undo the exponent, which means taking the square root of both sides. And so when I take the square root of the left side, that just cancels out the squared. So now I'm just left with x plus 5, and then that equals the square root of 3. Well, the square root of 3 is not a nice, pretty number. So we're just going to grab the decimal best we can. I'm just going to write down a rounded version, even though I'm keeping the entire decimal showing on my calculator. I'm just going to write down about 1.73. And then I change that to show approximately equal there instead of an equal sign, so that I remember that I rounded it. But you'll notice I just took the square root of both sides. A square root is an even root. And anytime you take the even root of both sides of the equation, you have to account for both the positive and the negative versions of your answer. And so we also will have a negative 1.73 over here. All right, now that I've done that, I can go ahead and finish solving them both out. And so I end up getting my two solutions of about negative 3.27 and negative 6.73. And now on to our next problem. And again, like the previous one, I want to get the power part of my equation isolated first. So notice that means I want to get rid of the plus 9 in this case. And so I now have negative 7 equals x plus 1 to the 7th. Now, if this were an even exponent, I wouldn't actually be able to find a solution here because it equals a negative number. However, because the exponent here is a 7, it is odd, I actually will be able to find that value. So I'm going to actually want to do the 7th root of both sides, which means raising the negative 7 to the power of 1/7. And when you go to type this in your calculator, remember those parentheses, or it's going to give you a tough time. All right, so if we do negative 7 to the power of 1/7, it ends up giving us negative 1.32. And again, we're having to round this. Now notice here, I have only one solution popping up. I'm not having to do both a positive and a negative version. That's again though because my exponent is odd. If my exponent up here was even, I would have to have done a positive and negative. But since it is an odd exponent, I don't have to worry about that. It's only one solution. All right, so our last thing to do here is we're going to go ahead and subtract the 1 from both sides in order to be able to move that over. Therefore, we can then see our answer is about negative 2.32. On this last problem, notice it looks fundamentally different than the last ones. This one is in factored form. And when it is in factored form like this, your goal is to set each of the individual factors equal to 0 because the whole thing equals 0. Now, this technique only works as long as the whole thing is set equal to 0, though. But thankfully, this one is set equal to 0. Therefore, I just need to figure out what makes each one of these sets of parentheses equal 0. So what plus 5 equals 0? Negative 5. And I can just keep going down the line and saying what plus 2 equals 0. And do that for every single one of those, and you have all of your solutions. And so then in this case, I would actually just say that x equals negative 5, negative 2, 1, and 2. And that's it. That's all you got to do there.